optional exam is the integral of 1 over x cubed plus 4x dx. The steps to solve this is we're doing this in partial fractions, so we're rewriting the terms into this, and then we're going to find our a and b values using algebra, and then we're just going to plug it back into the equation and solve for the integral. So the first step is to rewrite in partial fractions. To do this, we're going to have to factor out so we can figure out what it is. So x cubed plus 4x, the common term is x. We take that out here. And then it's going to be x squared plus 4. And x squared plus 4 can be further factored out into x plus 2 times x minus 2, as this is a square and this is a perfect square. Alright, now that we've done this, we can see what our a and b values are. So it will equal the integral of a over x plus b over x plus 2 plus c over x minus 2. And now we're going to use algebra to solve the equations. So we're going to use the numerator, so 1 will equal, and then we're going to basically multiply each variable here with all of these. So it would be a times x plus 2 times x minus 2, and the x is going to cancel out, so it would be a x plus 2 times x minus 2, and we're going to do the same for each variable. B, the x plus 2 will cancel out this time, so it's going to be x times x minus 2. And for C, the x minus 2 would cancel out, so it would be x plus 2. And now we're going to pick and choose our x values, so one of these variables are going to cancel out. So we're going to let x equal 0. One will equal a. 0 plus 2 is 2. 0 minus 2 is negative 2. And there's 0 here, and anything that has 0 is 0. So this is going to cancel, and it's just going to be b0. And the same thing with c. So the only thing we have to worry about is a, and since it's isolated, we can just solve for a. So 1 will equal negative 4a and that is going to make a equal negative 1/4. Alright, we're going to do this again. So we're going to let x equal positive 2. So when x equals 2, our a is going to cancel because 2 minus 2 is 0. Our b is going to cancel as well for the same reason. And our c is going to not cancel. So we will be able to solve for it now. Alright, so 2, sorry, not 2. When x equals 2, 1 equals 2 times 2 plus 2, which is 2 times 4 is 8, equals c times 8. And so our c will equal 1/8. I'm going to do this process one more time to find the b. It looks like if we use negative 2, every other value is going to cancel out as well. So we're going to have our x equals negative 2. 1 will equal a0 because negative 2 plus 2 is 0. Same thing for our c. Our b will not cancel out. Alright, so now we're going to do the same thing and solve for b. Negative 2 times negative 2 minus 2 equals, so it'd be 4 times negative 2, which is going to be positive 8. And our b is also going to equal 1/8. So now we're going to plug these values into the equation, so it would be like negative 1/4 over x, and we're going to just keep going through it. But we're just going to take this and put it at the bottom because it is a fraction. So our integral is going to look like negative 1 over 4 x plus 1 over 8 x plus 2 plus 1 over 8 x minus 2 dx. And this can just be further simplified out, so we can just do it in 3 separate integrals. That way it can be done a lot quicker. So when x is to the value of negative 1, as it is in this problem, just to be more clear, x to the negative 1 will equal the ln of x, and since the coefficient of x is 1, we don't need to do any u substitutions, we can just put it in right away. So it would be negative 1 over 4 ln x plus the absolute value of x, 1 over 8 ln x plus 2 plus 1 over 8, the natural log, x minus 2. We're going to input our constant of integration, and this will be our final answer.